What's up guys, Pete here, and welcome back to Proto-Write Productions. In today's episode, we're going to start a brand new series where I set out to build an open source universal test machine and an entire test specification around at-home 3D printing. If that's something that you find interesting, do me a favor, hit that subscribe button and come along for the ride. Now before you get your hopes up, this is the first episode in the series. There's not going to be any building, designing, testing, destruction, nothing like that quite yet. For now, I just want to get out of the way the what, the why, the how, and kind of go over the overall project. And then in future episodes, I promise we will get to actually building, testing, and designing all the stuff that we're going to talk about here. The first thing I want to get out of the way is the what. What am I physically trying to build here? For those of you who aren't familiar, a universal test machine is just a test device that lets us run a bunch of different material tests on different material samples. These are tests for tension, compression, bending, fatigue, all kinds of different things that help us characterize how a certain material behaves under certain conditions. The most common kind of test that we might run is something like a tensile test. You've probably seen this before. It's where we take a test sample like this, we slowly stretch it apart until it breaks, all the while measuring how much force we're applying and how much this specimen stretches before it fails. From there, we'll do a little bit of math in the background, plot that into what's called the stress-strain curve, and that provides us really useful data for how that material behaves. Now back in the day, this kind of information was kind of hard to come by for 3D printed materials. It wasn't until you had a group of independent reviewers and YouTubers like Tom Sandlanderer and Stefan from CNC Kitchen who started actually doing some independent testing to get this type of data for the community. Over time that evolved and grew, and eventually the OEMs did catch up, and filament manufacturers started providing this kind of information in technical data sheets with most of the filaments that they provided. Fast forward to today, and both of these things have increased a ton. Filament manufacturers almost always provide a technical data sheet for most of their filaments, and we have a ton of independent reviewers on YouTube like again, CNC Kitchen, Tom Sandlanderer, Edge of 3D, My Tech Fun, and probably a bunch of others that I can't think of right now, are all doing their own independent testing to provide this information to the community as a whole. So if we have all this information from filament manufacturers, and we already have a bunch of YouTubers doing their own testing on this stuff, why do I think we need yet another machine and, more importantly, yet another standard? I know, I can see the XKCD comment creeping in the background. I get it, I do. But I promise I have a couple of good reasons. Okay, well, the first reason is just that I thought this would be really fun and a good challenge, but we're going to set that aside. There are actually more altruistic reasons to do this, I promise. So there's kind of three main reasons why I think that this is worthwhile. The first is that while we do have the information provided by the manufacturers, it is always useful to be able to independently verify that data so that we know that there's nothing hokey going on with the testing that they're doing. On the specification side of things, you have a little bit of a gray area. Most of the specs that are being used for testing by most of these manufacturers were never intended for 3D printed materials. They're meant for more bulk processes, like getting a chunk of ABS and machining out your test coupons, or injection molding your coupons. These are all great for industry, but they don't make a ton of sense for the actual process that we're using. When you 3D print a part, it's not just the material properties, it's the whole process that comes into play. Now, to their credit, they're trying to take this into consideration. They'll do testing where you print the part in multiple orientations so that you can try and accommodate for things like layer strength. But again, there's kind of shoehorning test specifications into this realm of additive manufacturing. So a new standard that was built specifically around 3D printing and the limitations therein, I think has a lot of value in the community. And then the last point is actually about the community itself and all these independent reviewers who are doing their own testing. That testing is awesome. We really appreciate it. It's been a huge help to the community to see all of this different data points about the materials we use every day. But there is one kind of Achilles heel to the whole thing, and that's that every single person who's out there doing this testing is kind of doing their own flavor. Even if for the ones that are trying to do slightly more standardized tests, like per ISO 527 or the similar ASTM standards, they all have to make certain considerations for their setups, for their printers, for their testing machines. And because of that, you can't really compare apples to apples the data that you get from one reviewer to the next. If I'm trying to compare two different materials and they were tested by two different reviewers, it's really hard for me to draw any meaningful conclusions across those two data sets. Whereas if we had one unified test standard, one unified set of machines, and some way to calibrate those machines against each other, and that's kind of the crux of this whole issue, well, then we could take the data sets from all these guys over here and all these teams over here and pool them all together into a giant data set the whole community can use and really distribute the effort of testing all these different materials. That's kind of the ultimate goal, where we have this huge database of different materials submitted by independent reviewers, where because everyone's adhering to essentially the same standards and same guidelines, we can trust that data, put it right in the database, and have this huge pool of resource for everybody to use. So to that end, what I'm trying to accomplish here really has three main goals. The first is the design of the physical machine itself, and honestly that's probably the easiest. The second is the writing of a brand new test specification that everybody can use and adhere to. And the last and probably most important is figuring out some type of qualification, certification, calibration process, some way in which we can calibrate these machines against each other. That way we can actually meaningfully compare the data across different data sets, across different machines from different countries, because that's really the crux of the issue, not being able to compare data across all these different review points. That's what I'm setting out to do, and this is going to be a huge amount of work. I'm going to need a ton of help from the community here, both to make sure that I'm going in the right direction and to just help with the work itself. My background's in mechanical engineering, which means that stuff like software is way over my head, so any help on that side will be greatly appreciated. But obviously, if you have any interest in helping out with any aspect of this, from the spec writing to the machine design and testing to the certification and calibration process to the software writing, or if you just want to come along for the ride, do me a favor, hit that subscribe button because there's going to be a ton of content coming out. And please engage and get active with the community. Leave a comment down below. Eventually, I'll probably set up a Discord for this. Let me know your thoughts on the process. Let me know if you have any feedback on any of these things. This is going to be primarily a community-driven project, so the more community feedback we get, the better. It doesn't matter if at the end of the day I have a machine, a setup, and a test procedure that works for me. I need this to work for as many people as is reasonable so that we can have that distributed effort and have all of those resources shared across the community. In the next video in this series, what I'm going to go over is kind of the overarching requirements for this project, some things that I think are going to really help to narrow the scope for this overall effort and really help keep us pointed in the right direction. And I'm definitely going to need a ton of feedback on that video to make sure that everything makes sense and that it's going to make sense for as many people as possible. So be sure to keep your eye out for when that video drops. If you guys have any interest at all in mechanical, software, systems engineering, spec writing, qualification, certification, any of that stuff at all, or just designing and 3D printing stuff in general, come along for the ride and let's see what we can create together. Thanks again for watching, guys, and I'll see you in the next one.